Hello everyone, and welcome back to Revit Snippets, great tips you can learn in just a few minutes. Today we'll create in Revit this very nice interior style. As you can see, the ceiling is created from many timber slats. They vary in shape to create this very dynamic effect. And that's exactly what I have created here in Revit. If we now go to another view, you can see that's looking from the outside, and if I go to here, that's what you see from the top. And I'll show you how to do this today step by step. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's get started. I will close this project down, and we can start fresh from a new family. Go to conceptual mass and choose this template. We can do this here, the overall shape of the surface that these timber slats will try to follow. Now, that's the easy part. Let's go in here and set the work plane to be this vertical one. Next step, I can now draw a spline through points on this reference plane. And let's start from here. Make sure it's something wavy so we can see the full effect. Next step, I can select this line along with its control points and try to copy it along this direction. As you can see there, something is not going right. If I now click anyway, this line is moving but not on the horizontal direction. It's moving up. Let's undo this. The trick to resolving this is this. Select the line and the point still, but also select this host reference plane. And when you have them selected, press down the control key and just drag them to the right. You will see this small blue dash line, and that's when you know they are being copied in the right direction. Release now to copy. And there you have them. I can now modify this curve slightly, maybe bringing this point down and this one going up. We can now repeat the same step to have another additional profile. So select the plane, the point and the curve, press down Ctrl and drag it. With this new one, I can take this point really low like this. This will be the bottom point of our column, the one you see in this photo. And this one can go a bit down as well, but this one can go up instead. If I want to have more control over the curvature of this line there, I can now go to point, choose draw points on face, and then drop in here, maybe 2 more additional points. One here and one there. Because they are hosted, you can see they are a bit smaller than those already on the curve, and that's why when I select them like this, they don't give me the arrows to move them around. To show the arrows and to have those points affect the shape of the curve, I need to select them like this, go up to the option bar there, and choose to make point driving. Now, they have turned a bit bigger. If I now select this new point again, I have my arrows. Now I can use it to my advantage like this. Let's do the same for this other one. Select, make point driving, and then select it again. Now you have the arrows. Here we go. I can now select this and make another profile using the same technique. You can go for as many profiles as you like to create a complex surface. For now, for demonstration, I will finish with those 4. Let's now select them all like this and then choose create form. That will turn them into a single surface. You can see straight away, this will be the higher points on our ceiling, and this will be the lower point where the column is created. If you want to change the form slightly, just select it now, and then turn on X-ray. As you can see, my column here is a bit low, so let me try to bring this point a bit up like that. And the same for this point here. When you've done editing the surface, select it again and turn off X-ray. Here we go. Moving on, we can now turn this into a collection of timber slats. There are different ways to do this. Some people would even go as far as using Grasshopper, where they of course have more control on the whole process. But for today, because we are sticking with using Revit, let's use Dynamo instead. Just go to Manage and then open Dynamo from here. By the way, if you are new to Dynamo, don't worry because this script is super simple. Also, I will also include in the video description a link for you to download this script anyway. So even if you couldn't follow and create it yourself, simply download this script and then run it. Alright, let's now dive into using Dynamo to do what we need. I will first put them side by side like this. You have the Revit window now and Dynamo on the same screen. Let's go here to make a new definition. And the first step is to select this surface, just so Dynamo can have something to start from. Let's now right click and search for select face. Drop it on there. I can now use this button here, click it, and then select the surface in Revit. If I now turn on the background 3D view and then do zoom to fit, that surface is not there, not yet. This is a little bug in Dynamo. To make it appear, I need to now obtain boundary lines from the surface. So let's right click now and search for perimeter. That's the node we need, perimeter curves. Let's now connect this surface to there and then run the Dynamo script. Here we go. The bug is now resolved, and you can see now in the Dynamo preview window both the surface and these boundary lines. We can now switch back to the graph view. And before I forget, let's take a moment to save this script file. Just go to File, Save As, and we can call this one Wavy Ceiling. Likewise, we have to also save this Revit file here, Ceiling Mass. Now ready to create our slats. And the easiest way I've found to do this is by intersecting this surface with a series of vertical planes. To create those planes, we need to have for each one an origin point. So let's drop it here now, a point by coordinates node. This one here. It requires 3 inputs, which are the x, y, and z value of the new point. However, if you hover your mouse over each input, there's something that says default value 0. And you have that for each of the inputs. That means if you don't supply any values to here, the default point will be created at the origin location of the project, or family in this case. That point is here at 000, which is there. If I want to see it, I can as well. Just go to View, Background Preview, Available Previews, and click on Revit Background Preview. In Dynamo, I can go back to the preview as well and do a zoom to fit. Nothing there yet because I haven't run the script. Let's do run now. And now you can see that's the 3D point there at 0. We also have kind of an overlay on the geometry in Revit. The next step is for us to copy this point along one direction of the surface many times. To do so, I actually have to switch to using another point type, not reference point, but if I go in here and search for XYZ, it's this one we need. So, same idea, but instead of a reference point, it will give you a point. If I now delete this and run the script now, you can see that point is there even though it's smaller than before, because here it's just a Dynamo point, nothing has been created in the Revit mass. Anyway, it's time now to copy these points. To do so, instead of giving this just a default value of 0, I need to supply in here a number range. Let's now right click and then search for range. That's the one to use now. It will create for you a number range between a start and an end value, using a third value for the step. It's easier to understand if you can see it now in action, so let's do just that. I can now double click here on the canvas. That just brings up a code block for me. And I can now type in here something like 30,000 for 30 meters. We can now connect this to the end input. And for the step now, I can now copy this node by Ctrl C and paste it here by Ctrl V. The step for now, let's go for 1 meters and connect it to there. When I run this now, you will see straight away a number range starting from 0 to 30,000. Each number is 1,000 value bigger than the one before it. I can now connect this number range to maybe the Y input of this node and run the script. You can see straight away it has created for me many points, and these points are exactly 1 meter apart. There's a warning there, however, which is why the Dynamo node has turned yellow. If I hover my mouse over this warning now, I can see what it means. It's basically saying that everything is right, except from a setting we have for this Dynamo graph, which is called the Geometry Working Range. If I go now to Settings and then choose Geometry Scaling, the range already selected by default is medium. But many times in Revit, when you work on geometry of a building scale, we have to turn this scale now from medium to extra large. Let's do apply changes now, run the script again, and that will resolve that warning for us. Now before we move on, I can see that I have more points than I need now, so let's change the end value to maybe 20 meters. And try this again. Looking great already. I can now start creating vertical planes at each location point here. Let's now right click again and search for plane. The first section on the list here is what we need, plane by origin and normal. With this node here, I had to supply to it a list of origin points, which is right there. So let's connect it here. And for the normal, I need to give it a vector. Let's right click one more time and search for vector dot axis. That's the one there to use. We can now connect this to the normal input of the plane and run this script. If we now check out on the output, I have now 21 reference planes. It's hard to see here, so let's go to the background view again and do zoom to fit. You can now see those points, but not the planes, because by definition, a plane in Revit and Dynamo is an invisible object. However, even if you don't see them, they are still there, so I can move on to the next step, which is to intersect each plane to our surface. Let's do it now by right-clicking and searching for geometry dot intersect, and that's the one we need here. For this one, we have to supply two inputs. One is the geometry, which is the base surface we have there, and one is the reference planes we want to intersect this surface with. So, one step at a time, let's connect this surface here to the geometry input, and the planes can go to the other input. Run this now, and let's see the output. It's an empty list, probably because our planes are not facing the right direction. There's a way to try and fix this. If I right click here again, instead of the x-axis, I can choose to search for vector.y-axis. And let's try to replace this with that. Run this again. And then immediately you see now it's working. I now have a curve, which is the intersection result between a surface and a plane. Nevertheless, it's a bit disappointing because I have here now 21 planes and then only one curve coming back. The reason is this: we only have here one surface, so Dynamo kind of think to itself, well, if I have here two lists of different lengths, maybe I should stop processing as long as I have finished the shorter list. That's, however, is not what we want here. We want Dynamo to continue until the whole list of planes here has been processed. The trick to do that is to go here to the other input, click on this little arrow next to it, and choose to use levels. By default, it's looking at level 2, but if I now turn this down to level 1 and run this again, you will see I have here now 21 curves. If you're wondering what level 2 and level 1 means, it's all down here. This list, all the items on it are on level 1, as you can see at L1 at the bottom there. The list containing all those items, it is placed at L2. Before, this surface was intersect with the list here, which is at level 2, but now because I have taken this node to look at level 1, it is now mapping this surface to each of those 21 planes here. And that's how I can end up having all those 21 curves that I need. Alright, that's enough Dynamo for now. Let's bring this mass into a project. I can now go to File, New, and start the project from any template you like. I can now change back to here and load this family straight into this new project. We can now place it right here. Nothing shows, but if I go to 3D now, the surface is there. For the next step, we need Dynamo to continue and process this project instead of this family. The trick to do this is to save the script and then close Dynamo. We can now go back to Manage and then open Dynamo one more time from here. I can now open this script again, and that's how you can tell Dynamo to stop looking at the mass family and from now on continue to process only in this project. We can then reselect this face, click on Select, pick its face here, and run the script. Here we go. Because we place this mass in the project, however, we need to now also move it slightly. So the origin point, which is there, is somewhere near this corner of the mass. Let's go to Modify, choose Move, and I'll take this corner here and bring it somewhere there. Run this again. And now we have what we need. Alright, it's time now to create some 3D objects for our slats. We can start from here, the list of nerves curves. Let's first flatten this list. just search for flatten and drop this one in. Bring this to there, run this, and now I have all those curves on the same list. And I want to copy those curves up because they are now showing the bottom of our slats. It's the top we need as well before we can create the slat geometry. To copy those curves up, just search for another node called translate. When you go down this list of results, there's a little preview window here on the left hand side, as you can see. Go through this list until you can see this one where it says input, geometry, direction and distance, because we need all three inputs for this node to work. Let's click this one here to place it. For the geometry, it's obviously our curves here, so let's connect this to geometry. For distance, I want to copy those curves up, so it's the z vector I need this time. Let's search for vector.z. And it's this one here I need now, z-axis. Connect the z vector to direction. And now we need to specify this distance, which will be the height of each slat. I can now double click here on the canvas now, and how about we can use 500. Connect this to there, and let's run the script. Perfectly, now it's working just like it should. You now have one curve additional to each curve on the surface. We can now combine the top and the bottom curve of each slat. Let's right click one more time and search for list.create. This is a variable input node. That means I can now click on this plus sign here to give it a second input port. For item 0, we can connect these curves to there. Remember, these are the original curves on the surface. And for item 1, I can connect the copied curves to there. Run this now. And now if you check on the input, you have here the first list, which are the curves on the surface, and the second list for the curves on top, the ones we just created by copying. Anyway, it's slightly different from what we need, because for each slat to be generated, I want to have its top curve and this bottom curve on the same list. That's for the first slat. For the second slat, I want this top curve and the bottom curve of that second one to be on the second list, and so on. To do so, you need to change this list now to combine the first item here to the first item there, make that a list, and then combine the second item here to the second item there, make that a second list, and so on, until we have all those curves processed and grouped properly. That's actually super easy to do. Just right click here now and search for transpose. This one here. When I connect this list to there, let's see what happens. That's exactly what I wanted. So I have here now these two curves for the first slat, these two for the second one, and these two for the third one, and so on. If you want to check for yourself, just double click here again and type in list and then 0 in square brackets. This is for us to get the first item in this list, so I can try to connect it to there. Run this again. When I select this now, you can see, if I go back to this 3D preview, those two curves here for the first slats, they highlight up, and that's how I know I got the right elements. It's also easier to check if you now select all those nodes before that node, right click on the canvas, and choose to hide geometry preview. Now only those two curves are showing. Anyway, I'll turn the rest of them back on, because then it's easier for me to see where to go next. And this one, we only needed it for testing, so I can now also delete it. Everything is now ready for us to create the surface for our slats. Let's right click here again and search for surface.byLoft. This one here. I can now just connect these curves to the cross-sections input and then run the script. Here we go. We have now the surfaces we need for our slats. Before I move on, however, there's something we need to look at, which is this column here. If I go to maybe the front view, you will see level 0 is there. If I now bring this level there, it's now obvious that we need to cut off any surface that goes under level 0. If I now turn to Dynamo, go to background preview, it's the bottom of those slats here we need to cut away. That's super easy to do actually. Let's go back to Revit now. And I can just draw in here a floor. from the top view, go to architecture, floor, and let's draw a rectangle here. Usually we need this anyway, because our building will need a ground floor element. And here it is. I can now go back to Dynamo, right click, and search for select face. Now similar to before, I can click on this select button there, and this time pick on this top face of this floor. Run the script now, and you can see the surface is there already. Let's now turn this into a solid so we can use it to cut away any unnecessary portions of our slats. To do so, I can right click again and search for surface.thicken. Choose the one that has the both sides input, as you can see in the preview. It's now straightforward. We can now connect the surface there. For thickness, I need to give it a value big enough to cut away the whole thing below level 0. Let's double click here now and give it a big value like 3 meters. Don't worry, this won't turn into anything in Revit, so you don't have to go real with this thickness. Just be generous here, so this surface can be extruded down deep enough to cut away anything you don't need. Let's connect this thickness to there, and then for the both sides input, we'll look at this in just a moment. I can run this now, and here's my solid, created by thickening that surface there. Anyway, something interesting happens. As you can see in Revit there, our surface, the top face, is now in the middle of the solid. And that's because we didn't change this both sides input. The default value there is true. That means if I give this value here a thickness of 3 meters, it will create a 1.5 meter positive offset and a 1.5 meter negative offset for the solid. That can be what you need sometimes, but not here in my case. So to disable this feature, I will go here and right click, then search for Boolean. It's the one there that says TF, click on it now. And it's just a way to say either you want something on or off. Because now we want this feature off, I can now set us to false and connect this to there. We can now run this again, and finally I can see the extrusion going in one direction. It however has gone in the opposite direction. I want it to go down, but it's now going up. No need to worry, just go here now to thickness and flip this value from plus 3000 to minus 3000. Run this script again, and finally that's the solid we need. I can now zoom out a little and choose to cut those surfaces using this solid. To prepare for that, however, I need to turn those surfaces first into solids themselves. Let's do another surface.thicken node here. And go for surface, connect that to surface there. The thickness here will be the thickness of our timber slats. Let's go for something smaller. How about 50? And connect it there. I'm gonna run this now. And sure enough, it should create 3D objects for our slats. Let's go back to 3D preview. And you can see now our slats, they have now real thickness. It's time for me now to cut these using that solid there below. There's one note specifically for that, and that's called solid.difference. This one here. The first input should be the solid to be cut, so I will connect this to here now. And other is the other solid that we can use as a cutting tool. We can now connect this solid here to there and click on run. To see the result clearer, I will now turn off whatever before this node by hiding geometry preview. And it's not what we really wanted, because here it only has one solid coming back. The reason is we once again have lists of different lengths. If I now expand this, for example, I have here 20 solids, but over here I have only one solid. Without us saying anything, Dynamo just say to itself, well, let's map this solid here to this one here, and when it moves to the second one, because there's no second item here corresponding to that second item, it just stops processing. And that's how you end up having only one solid coming back from this operation here. We've seen this before earlier today, and the fix here is the same. Just go here to the solid input, click on this arrow next to it, choose to use levels, and change the level here from L2 to L1. Click run again, and now when I examine the result, you can see straight away our slats are all there, and the ones that go below level 0, they have been cut back just like we expected. Anyway, remember, everything we see here is Dynamo geometry. If I go to View, Background Preview, Available Previews, and turn off Revit Background Preview, you will see straight away that in Revit we haven't got anything yet. That surface is there, but that's just the mask we brought in at the beginning. To bring those 3D slats into Revit, we need to do an extra step here. Let's first flatten this list. Using flatten, connect to here. Run it now, and it does nothing special except from turning those solids from one per list to all the same under one single list. Now from here I can bring those into Revit as import instances. There are people warning against this method, but so far, as of the time of this recording, this is still the only reliable way to bring geometry from Dynamo to Revit without modifying or triangulating them in the process. So let's go with this method for today. I can now right click and choose to search for import instances and choose this one by geometries plural. We can now connect this to here now. Save the script because this can take a while for big collections of objects, and then click on run. Here we go. If I now go here now to Revit, go to masking and site, turn off masking. We only have these nice 3D slats in our file. Anyway, if I go back to the reference image now, of course we want them to be timber slats, so let's see how we can give them this material. Just go to Manage, choose Object Styles, go to Imported Categories, and in here that's where you can change the material. If I now click on this now, let's say we rename this material to something else. How about timber? Then we can go to Appearance, click on this Replace Asset button. Go to Physical Assets, go to Wood, and you can go for your own timber material, but for now, I'm going to go for cherry. Double click there to bring it in, close this window, and now it's there. I can then go to Graphics, and tick on this box to use the overall color of this bitmap as a shading color here. Let's do OK twice. And there you have them. Timber slats now are in timber. Okay, so far so good. But if you look at the reference image now, there's a big difference. Because those slats, they are very close to one another. Much closer than they are now in our Revit model. The good thing is, because we've done them in Dynamo, it's now super easy for me to go back here to the beginning of the script and just change this step value from 1 meter to something smaller. How about we go for 200? Save the script again because now we have more elements to generate and import. It could take a while to process. Always save your Dynamo scripts when you get to a critical point when you know it's going to be heavy for the system to cope. When you have saved it, click on run again. It should now create 5 times the number of slats. Okay, looks much better now. If I go to Revit, the whole system is there. But the color is wrong again. Anyway, we know how to fix this. Let's go back to Manage Object Styles. And this time, this material is overwritten every time you redo the import, but you can always set it back to something you need. Timber. And that will change the whole system for you. That's now exactly what we need. Of course, the reference image has more of a wavy effect because the ceiling system goes down to the ground at more than 1 point. 1 point is here, another point there. But for today, of course, we only do with 1 point to show the principle. If you want the system to touch the ground at more points, simply go back to this mask family, edit the surface, bring it back into the project here, and then rerun this Dynamo script to give you more slats coming to the ground. You can then create other elements of the building, like the curtain system, the furniture, to eventually get to something like this, which looks very nice, but didn't take that long to create in Revit. Alright, if you enjoyed this lesson and want more like this coming every single week, make sure to subscribe to this channel. For now, practice creating this ceiling, either from scratch on your own or using the Dynamo script you can get from the video description. Learn from the process, and I'll see you in the next lesson.